Alright, in this problem we're given y double prime minus 2y prime plus y equals e to the x ln x, and this happened to be a second order linear non-homogeneous equation. Therefore, we need to solve for the homogeneous part first, which is y double prime minus 2y prime plus y, and set the e to the x ln x equal to 0 instead. And using the auxiliary equation, we're gonna get m squared minus 2m plus the y there is just gonna be 1 equals 0. And in solving for that, we're gonna get a repeated root of m equals to 1. Therefore, our solution to this homogeneous equation is gonna be y, I'm gonna call it y sub c equals c1 e to the x plus c2 e to the x again, but then we're going to have this e to the x and you need it to be linearly independent, therefore I'm going to have it multiplied by the x right there. And after getting that, this is this part right here. Now, in solving for the non-homogeneous part, the e to the x ln x, I'm going to use variation of parameter, and to solve for that, we need to use the Wronskian, which I've listed down here. So in solving for those, I would get w equals, I'm just going to go ahead and list the y1, y2, and the derivative there, which is e to the x e to the x, and then the derivative of e to the x is just going to be e to the x. Products rule here, and you'd get e to the x plus x e to the x. And you would get, so when you're multiplying these two, subtract these two wings right here, you would get e to the 2x. That's your solution there for the Wronskian. And for W1 and W2, you do the same thing, but instead your f of x here is going to be whatever that is on the right side of the equation. And you're going to get W1 is negative x ln x e to the 2x, while your W2 is going to be e to the 2x ln x. Alright, now that we've had all the W1 and W2 that we needed to get our derivatives here for the U1 and U2, the reason why I'm doing U1 and U2 is because later on you can plug it back into here and get this particular solution for this differential equation with the non-homogeneous part. Alright, in solving for the U1 prime, you're going to put W1 over whatever the Wronskian solution that you had earlier. So that would be this part right here, negative x ln x e to the 2x, all over the Wronskian part, which is e to the 2x. This part cancels out, and you are going to end up with negative x ln x. And that is the derivative. So to find u1, you would need to take the integral of that. So in doing the integral of u1 prime, this is a integration by part. I actually Wolfram alpha it, and I got negative 1 over 4 x squared times 2 ln x minus 1. Okay, so that is what I got for U1. I'm going to go ahead and box that just a little bit. And then same thing for the U2 prime there. I did the same thing. I put W2 over W. This e to the x is one that's again going to cancel out, and I'll get ln x. And integrate that, and I end up with U2 equals x u2 is x ln x minus 1. Okay, so I got u1 and u2. And now I'm going to multiply those two with the solution that you got for your y1 and y2 from this upper part right here. And then later on for your general solution, you're going to add those two together, the solution that you got for your particular solution, which is right here, add it to the solution that you got from your homogeneous part. And you are going to end up with the general solution equals -1/4 x squared e to the x. The x squared part's from here. E to the x is whatever I got for my y1. And whatever followed there, 2 ln x minus 1 plus x squared e to the x ln x minus 1. And now that's just your particular solution, and I have to add it to your the solution that we got earlier for the homogeneous part, which is just that c1 e to the x plus c2 x e to the x. And there goes your big solution. That's it.